Okay, so here's the chapter 2 test review. So what I did is I selected a couple of problems from the chapter test review from the textbook, and I figured I would just go through them and show you how to do them. All right, so question number 1 reads, a parabola has an axis of symmetry of y equals 3 and passes through the point 2 comma 1. Find another point that lies on the graph of the parabola. Okay, so let's do a rough sketch of this just to kind of get an idea of what we're looking at here. So I'll draw a coordinate plane. Boom. Boom. It has an axis of symmetry of y equals 3. So y equals 3 is here. And it passes through the point 2 comma 1, over 2, up 1. Okay, so my parabola probably looks something like this. Oops. Boom, right? It could face the other way, but it doesn't really matter. So, because the axis of symmetry is a y equals equation, I know that this is a left or rightward facing parabola, right? Because the axis of symmetry has to go right down the middle. Now, the way this question is done is you're utilizing the fact that a parabola is symmetric about its axis of symmetry. So if this point 2 comma 1 is on the parabola, that means directly across the axis of symmetry should be another point that the parabola passes through. Right? So directly across the axis of symmetry is the same x coordinate, right? So right here is going to be 2 comma something. And how do I figure out what that something is? Well, if from the axis of symmetry to that point it's 2 units down, then from the axis of symmetry to the next point it should be 2 units up, which would be 5. So 2 comma 5 also has to be on the parabola because of that symmetry. All right. Number 2 reads, let the graph of G be a translation 2 units left and 1 unit down, followed by a reflection in the y-axis of the graph f of x equals 2x plus 1 quantity squared minus 4. Write a rule for G. Okay, so this sounds confusing, write a rule for G, but all it's saying is write an equation for G, right? What is G of x equal to? So if f of x is equal to 2x plus 1 quantity squared minus 4, and G is a translation of that 2 units left and 1 unit down, well, all you do to go 2 units left is you add 2 to this value here, and you actually, you know what, let's be careful. They've made this tricky. This is not in vertex form. Let's put this in vertex form to make sure we're doing this correctly. So to get this in vertex form, we're actually going to have to simplify this out. So 2x plus 1 squared is equal to 2x plus 1 times 2x plus 1, which is equal to 4x squared plus 4x plus 1. And then we still had that minus 4 out there, so we're going to add that in now. So this is 4x squared plus 4x minus 3. Now to put this in vertex form, you will factor out a 4 from the first two values. 4 times x squared plus x plus some unknown value minus 3 minus that same unknown value. So I'm doing what's called completing the square to put this in vertex form. To figure out what goes here, I take my b value, which is 1. I divide it by 2, and then I square it. 1 over 2 squared is 1/4. Now I'm adding 1/4 in here, and so what I'm really adding is 4 times 1/4, which is 1. So I have to also subtract that out here. And then I finish this off by simplifying this. This becomes x plus 1/2 quantity squared. If you were to factor this, you would see that it becomes x plus 1/2 and then minus 4. So now my equation is in vertex form. F of x equals that. Now, if I shift it 2 units left and 1 unit down, all that means is I'm adding 2 here and I'm subtracting 1 here. So g of x, my new equation, would be 4 times x plus 5 halves, 2 plus 1/2, minus 5. that's all you do. So the first thing I did was I put this into vertex form, and then I just shifted it using our translation rules. All right. This problem, it wants us to identify the equation of this graph. All right, no problem. So with this graph, we have a little bit of information given to us. We know the x-intercepts, and we know a point that the graph passes through. My x-intercepts are going to be -1, 0, and 7, 0. Perfect. So I can immediately put that into intercept form, which is f of x is equal to a times, in this case, x plus 1 times x minus 7. Right, so you just flip the sign on these things and you put them in parentheses next to x. Now I can find that a value by simply using this other point that the parabola passes through. That point is 5, 3. So I can say that the f of x value 3 is equal to a times the x value 5 times 5 minus 7. So all I did was I plugged in 3 for f of x and I plugged in 5 for x. And then I just solved for a. A times 6 times -2. So a is equal to, 3 is equal to -12a, or a is equal to -1/4. Perfect. So my final equation is -1/4 times x plus 1 times x minus 7. Boom. Next problem is a real-life quadratic application. A surfboard shop sells 40 surfboards per month when it charges $500 per surfboard. Each time the shop decreases the price by $10, it sells 1 additional surfboard per month. How much should the shop charge per surfboard to maximize the amount of money earned? Okay, so the shop sells 40 surfboards per month when it charges $500 per surfboard. All right, so the amount... Okay, so the price of each surfboard is going to be 500 minus 10 times the number of surfboards that they're decreasing by. So every time they sell 1 additional surfboard, this price goes down by $10. And the quantity of surfboards that they sell is going to be equal to the 40 per month plus each additional surfboard. So these two equations represent the price per board and the quantity of boards that they sell. Now the revenue that the shop makes is equal to the price times the quantity of boards. So the revenue as a function of the number of surfboards that they sell is equal to the price, 500 minus 10x, times the quantity, 40 plus x. Now, I don't know if you recognize this, but this is a quadratic function written in intercept form. And so all you do now is simplify this out. So we'll go ahead and multiply this through. 500 times 40 is equal to 20,000. Plus 500x minus 400x, I'm just foiling this, minus 10x squared. So the r of x, the revenue as a function of the number of surfboards sold, is negative 10x squared plus 100x plus 20,000. Now, this is a quadratic function that has a maximum value at its vertex. And so if we just figure out what the x value of the vertex is, that'll tell us how many surfboards the company should sell in order to maximize its revenue. Okay, and to find the x value of the vertex, you just use the equation negative b over 2a, which in this case would be negative 100 over 2 times negative 10, which is simply 5. So the company, so if x equals 5, then the number of surfboards that they should sell per month is 45. 40 plus x, which is 45. Great. In the last problem here, graph f of x equals 8x squared minus 4x plus 3. Label the vertex and axis of symmetry. Describe where the function is increasing and decreasing. All right, sounds good. So let's start by getting the vertex. So we know the x value of the vertex is negative b over 2a, which would just be negative 4 over 2 times 8, which would be 4 over 16, which is 1 over 4. So the x value of the vertex is 1/4. To find the y value of the vertex, you just plug that number in for x. So 8 times 1 over 4 squared minus 4 times 1 over 4 plus 3. which would be 8 over 16 minus 1 plus 3, which is 1/2 minus 1 plus 3, which is equal to 5 over 2. So 5 over 2. So there's our vertex. Our axis of symmetry would simply be x equals 1/4, because it's just x equals the x value of the vertex. And then to graph it, make a little coordinate plane. Boom. Boom. We'll graph our vertex, which is at 1/4, 5/2. And then our, we'll get a couple more points on it. So we'll figure out when x equals 1, what does y equal? When x equals 1, we have y equals 7. And when x equals -1, we have y equals 16. 15, sorry. So over 1, up 1, 2, 3, 4, 5, 6, 7, and then -1. So it's going to be something like that. Okay. Now it wants us to say, where is the function increasing or decreasing? Okay, so to say increasing or decreasing, you read the graph from left to right. So the function is decreasing from -infinity up to the vertex, the x value of the vertex, which is 1/4. That's where it's decreasing. And then it's increasing from 1/4 up to infinity. Increasing. Boom.